In this video, we're looking at how to do binomial expansions with a method that involves combination. All right, but in the previous video, we looked at how to expand binomials with smaller exponents or smaller powers and using the Pascal triangle. Then we made some few observations which will be very important in this aspect as well. We said that if you're having a binomial to the power n, right, the number of terms should be n plus 1. So for example, to the power 3, the number of terms are 4, right? 1, 2, 3, 4. Then also we said that the power of a in a binomial, right, decreases from n to 0. So decreases from 3, a to the power 3, 2, 1, 0. And then the power of b increases from 0 to what? N, right? So the power of b increases from 0 to what? 3. All right. Then again, we said if you sum the powers of a and b, in each term, we should be getting what? N. So if you sum the powers of a and b, right, you should get in the power of the binomial. So 3 plus 0, 3, 2 plus 1, 3, 1 plus 2, 3, and then 0 plus 3 is what? 3. All right, these are some of the few things we talked about, which will be needed over here too. And using this approach, the only difference has to do with the coefficients, all right? Has to do with the coefficients. In a previous video, we used the Pascal triangle to write out the coefficients. But in this video, we are not going to use the Pascal triangle, since if the power of the binomial becomes big enough, creating the Pascal triangle to, for example, let's say the 20th power or to the 50th power would involve a bit of a work to do. Therefore, this method will be appropriate. So now let me explain the this combination. So this is n combination r, which can be written as this, n combination r. Let's say, so if you have n combination r, we say that it's equal to n factorial over r factorial times n minus r what? Factorial. So for example, if we have, let's say, 5 combination 2, right, which we can write as 5 choose 2. See, this will be equal to, I said, n factorial, so the 5 factorial over r factorial, so over 2 factorial, times n minus r factorial, so 5 minus 2 factorial, 5 minus 2 factorial, right? Good. And this is equal to, 5 factorial is 5 times 4 times 3 times 2 times what? 1. Okay, 5 is going to multiply the integers in the reducing order to 1 over 2 factorial is 2 times 1, okay, times 5 minus 2 is what? 3. So you are having 3 factorial, and 3 factorial is 3 times 2 times what? 1. Okay, then you simplify this. Actually, this is very simple. As you can see, 3 times 2 times 1 is going to give you the same result as 3 times 2 times 1, right? So this can cancel out this, right? Good. And then 2 times 1 is 2. So 2 goes here 1, and then 2 will go into 4 how many times? 2. So now you're left with 5 times 2, which will give us what? 10. All right, so 5 combination 2 is what? 10. Actually, you can do this with your calculator. All right, you can do this with your calculator. So you go onto your calculator. There's the key that holds the combination function, right? This key you see over here. And so you see the color is yellow. So we punch 5, then you press shift, then you press that key. Okay, so 5 combination, then you press what? 2. Okay, then you press equal to. See, we are getting 10. All right. If I should give you another one like 8 combination, let's say 8 combination 6. Okay, 8 combination 6. This is 6. Okay, 8 combination 6. So this will be equal to 8 factorial over 6 factorial times 8 minus what? 6 factorial. Is that right? Good. You can rewrite this one as, which is the same as, I want to write this one first. 8 factorial over 6 factorial times 8 minus 6 is what? 2 factorial. You see that? So this will be equal to, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right? All these over 6 factorial will be 6 times 5 times 4 times 3 times 2 times what? 1. And then all this times, 2 factorial is 2 times what? 1. Is that right? Good. So if you're able to do this, then you realize that, see, 6 times 5 times 4 times 3 times 2 times 1, okay, can cancel out this, like that. Okay, so now you're left with 8 times what? 7 over 2 times what? 1. And as we know, so 8 times 7 is what? 56. Okay, 56 over 2 times 1 is what? 2. And you have 56 divided by 2, the unit was 28. Alright, and so 8 combination 6 will be equal to 28. We can do this too with your calculator. So you just get your calculator and punch 8, then you press shift, then press combination what? 6, then you press equal to, then there you are, 28. Alright, so let's get into it. As I said, this method is very important, and then we have to know that, because when the powers of the binomial becomes big enough, you cannot be using the Pascal triangle. So let's get into it. For example, we use the Pascal triangle to expand this, a plus b to the power 3. So let's try and see the combination approach. It's actually the same thing. The difference is only about the coefficients. So if we have a plus b to the power 3, right, this will be equal to, now all the things about the powers and then the terms in the binomial are the same. Okay, so let me leave a space for the coefficient. And so as we said in the previous video, the power of a will reduce from 3 to what? 0. So we have a to the power 3, and then b increases from 0 to what? 3. So a to the power 3, b to the power 0. Okay, plus, let me leave some space for the coefficient. The power of a reduces and then b will increase. Okay, plus the power of a reduce and then the power of b increase, plus space for the coefficient. The power of a reduces to 0 and b increases to what? 3. All right. So for the coefficient, look at it. It is always the power. Okay, so 3 combination, right? So the value we are going to have down here is going to be the power of what? The second term in the binomial, which is 0. Then when you come here, 3 combination, what is the power of the second term in the binomial? 1. When you come here, 3 combination, the power of the second term of the binomial, 2. Then when you come here, 3 combination, the power of the second term of the binomial, 3. Is that right? Good. So the 3 we have over here is constant for all the terms, but then the value we are going to choose, okay, is always the power of the second term of the binomial. Okay, it's the value of the second term of the binomial. All right, this one is the power of the second term of the binomial. I'll do this, the first and the second, then the others we can punch with your calculator. You can try that. So if you have 3 combination 0, we said this is equal to 3 factorial over 0 factorial, 3 minus 0 factorial, right? Good. And then 3 factorial is 3 times 2 times 1, right? Over, 0 factorial is equal to 1, right? And then 3 minus 0 is 3, right? So 3 factorial will be 3 times 2 times 1, right? And then this whole thing will go here 1, this will go here 1. So this is equal to 1. Is that right? So 3 combination 0 is equal to 1. And then we are having a to the power 3. B to the power 0 is 1. So we leave it like that. plus, when you come here, 3 combination 1. Actually, you can do this on your calculator, which is pretty fast. So you just punch 3, then shift combination 1, then you press equal to, and then you'll be getting what? 3 a to the power 2 b, plus, when you come here to your calculator, 3 shift combination 2, then equal to, you'll be getting what? 3, and then a, and then b squared, plus 3 combination 3 on your calculator, 3 shift combination 3 equal to, you get what? 1. Okay, a to the power 0 is 1, and then b to the power 3, and then that is it, which is actually the same result we are getting when we used the Pascal triangle. Okay, all right. So actually, the issues with the first term and the second term of the binomial in the expansion are the same as we did in the Pascal triangle, but the only difference is the coefficients. Over here, we are using the combination, and then over there, we use the Pascal triangle. You know, this looks a bit simple, and then you realize that when the powers of the binomial becomes very big enough. Now, let's take another example. This question says, without fully expanding, write down the first 4 terms in a binomial expansion of this. Okay, you want to write the first 4 terms of this binomial without fully expanding. So we are not going to necessarily expand everything. We just want the first 4 terms. So let's quickly look at the solution. We have 3 minus 2b to the power 5. All right, this will be equal to, there are 3 things you have to think of: the coefficient, and then the powers of the first term, and then the powers of the second term. Okay, so let me leave some space for the coefficient for now, and then we know the powers of the first term in the binomial will reduce from 5 to what? 0. Okay, so it means you're going to have 3 to the power 5, and then the power of the second term increases from 0, so into bracket negative 2b to the power 0, plus, let me leave some space for the coefficient. We have 3 to the power what? 4, then this one will be negative 2b to the power what? 1, plus, let me leave some space for the coefficient. We have 3 to the power 3, then negative 2b to the power what? 2. Let me continue this over here. And they said the first 4 terms, so first term, second term, third term, then you're left with the 4th term. So plus, now the power of the first term decreases, so we have 3 to the power 2, and then negative 2b to the power 3. And then we have the first 4 terms, plus the other terms, we don't need them. Okay, so we put 3 dots to show that it continues. All right, so now we use the combination to write the coefficients. So as we said, we will be having 5, choose, the value down here is going to be the power of the second term of the binomial, 0. Then 5, choose the power of the second term of the binomial, 1. Then we have 5, choose the power of the second term of the binomial, 2. Then when you come here, we'll have 5, choose the power of the second term of the binomial, 3. All right, so now we just simplify quickly, then we get the answer. Now we can use the calculator to do this. So we punch 5 combination 0, and then we are getting what? 1. Okay, 1, so I won't worry myself to write that. And when you come here, negative 2 to the power 0 is what? 1, so I won't write that as well. So 3 to the power 5 would give us 2, 4, 3. All right, so that's for the first term. When you come to the second term, 0.5 combination 1 will be giving us actually 5. Okay, on your calculator, 3 to the power 4 is 81 times negative 2 to the power 1 is same as negative 2. Okay, and so this will be giving us negative 810 minus 810, then you have times b. Okay, good. Then when you come here to 5 combination 2 on a calculator, 0.5 shift combination 2, you're getting what? 10, and then times 3 to the power 3 is 27, okay, times negative 2 to the power 2 is positive 4, and then this should be given us on a calculator 1080, okay, 1080. So we are having plus 1080 b squared. Good. Then actually we're left with the last term. On your calculator, 5 combination 3, we are getting what? 10. Okay, 10 times 3 to the power 2 is 9, times negative 2 to the power 3, you get negative 8. Okay, if you multiply this, you should be getting negative 720. Okay, so we are having minus 720 b to the power 3 plus dot dot dot. Okay, so actually these are the first 4 terms of this binomial expansion. If you use a Pascal triangle, you should be getting the same results. Now let's look at another example. This one says that write down and simplify the first 4 terms in the binomial expansion of 2 minus x to the power 12 without fully expanding. Okay, so this is what we are saying, that if you have to use a Pascal triangle, it means you have to create the Pascal triangle to the 12th power. But over here, we use the combination approach. So you have 2 minus x to the power 12. 2 minus x to the power 12. This is equal to, so we have 12 combination 0. Okay, remember we said this is the same as 12 combination 0, right? Good. So 12 combination 0, that's the coefficient, and then the power of the first term in the binomial will decrease from 12 to 0. So we have 2 to the power 0, 2 to the power 12, and then the power of the second term of the binomial will increase from 0 to what? 12. So we have negative x to the power 0 plus 12 combination 1. Okay, so no one has to tell you this. Probably you should be getting the pattern now. There's no need to write the first and second term of the binomial first before you come and give out the coefficient. From now, you should know the pattern. All right, the number is the power of the binomial, and the choose is the power of the second term of the binomial. Okay, all right, so 12 choose 1 times 2 to the power 11. Okay, the power of the first term reduces, and then negative x to the power what? 1 plus 12 choose 2, and then 2 to the power is going to reduce, so 10, and then negative x to the power is going to increase 2. Right, remember every time you add the powers you have over here, you should be getting the power of the binomial. Okay, 1 plus 11, 0 plus this is 12. Okay, the question is asking for the first 4 terms. Okay, so the first, second, third, you're left with the last term, so plus 12 choose 3, and then 2 to the power 9, negative x to the power 3, okay, plus the 3 dot to tell that the expansion continues. You know, you have to simplify. Quickly, you can use your calculator. If you don't want to use your calculator to, as we said, 12 combination 0 is the same as 12 factorial over 0 factorial times 12 minus 0 factorial, and this is equal to 12 times 1. This is a bit lengthy because there's no need to worry yourself to do this anyways. You can just see that 12 times 11 times 10 times dot 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 times 2 times 1, okay, over 0 factorial is 1, okay, times 12 minus 0 is 12. So times 12 factorial again. Then you have 12 times, in fact 12 factorial is 12 times 11 times 10 times dot 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 times 2 times 1. Okay, just as we have in this case. And then this goes here 1, this goes here 1. So it's actually equal to 1. Alright. So 12 combination 0 is 1. And then negative x to the power 0 is also 1. So now we're left with 2 to the power what? 12. Okay, so 2 to the power 12 will give us 4096. Okay, all right, good. Plus when you come here 12 combination 1, if you do this, you're going to get 12. Okay, times 2 to the power 11 will give us 2048. Okay, and then negative x to the power 1 is negative x. All right, plus when you come here to 12 combination 2, if you do that, you get 66 times 2 to the power 10 will give us 1024. Okay, times negative x to the power 2 will give us positive x squared. All right, then plus 12 combination 3 will be giving us 220. You can check that with your calculator. And then 2 to the power 9 is 512. Okay, times negative x to the power 3 will give us negative x to the power 3 plus dot dot dot. Okay, so then we simplify and write the final answer. 4096. Sorry, this will not be plus. Okay, minus because of the minus over here. 12 times 204, 24576, 24576x plus you do this 6 times 1024. Now suppose you be getting 67584 x squared, right? Minus, see, because of the minus we have over here, 220 times 512 on your calculator, and I suppose you'll be getting 112640 x3 plus dot dot dot. All right, so these are the first 4 terms of the binomial expansion. Okay, now let's take another example, and that will actually be our last example. This one says that if you find the coefficient of the s cubed term of the binomial expansion of 2a minus x to the power 6. All right, so what this one is interested in is the coefficient of the term that has x to the power 3. That is what the question is interested in. You agree that you won't worry yourself to do all the expansion. So let's quickly look at the solution. We have 2a minus x to the 6th power. So this will be equal to, going for the combination. So we have 6 choose 0 or 6 combination 0. The power of the first term reduces. So we have 2a 6, and then that of the second term minus x increase from 0. Okay, so this is the first term plus 6 combination 1. Okay, then 2a will reduce from 6 to 5, and then this one will increase from 0 to, so we have negative x to the power 1. Okay, increase from 0 to 1 plus we have 6 combination 2, actually 0 1 2, you see, so the choose will be increasing. Then 2a reduces to 4, and then negative x increase to 2. Okay, let me continue over here. Plus, now we have 6 choose 3. Good, so we have 6 choose 3. Then 2a the power, then you have 2a the power will decrease to 3, and then negative x the power will increase to 3. Good. Now you agree with me that we are looking for the coefficient of the term that contains x to the power 3. Right? Good. So it means when we get here, we can stop and see that class ... Let's simplify this and then write out the answer. Now 6 combination 0 will give us 1, and the negative x to the power 0 also gives us 1. So now you're left with 2a to the power what? 6. Alright, so 2 to the power 6 will give us 64, and then a to the power 6. Good. 6 combination 1 is 6 times 2 to the power 5 will give us 32. 6 times 32, which will give us 192. We have 192, but because of the negative we have over here, we have in minus 192x. And then a to the power 5, a to the power 5. Actually, this should come before this. I would write that in the next line. Okay, then you come here plus 6 combination 2. When you do that with your calculator, you get 15 times 2 to the power 4 will give us 16. Is that right? Alright, so 15 times 16 should give us 240. Okay, so we have 240 a to the power 4, and negative x to the power 2 should give us positive x to the power 2. Alright, good. Then the last one, 6 combination 3 will give us 20 times 2 to the power 3 will give us what? 8. Alright, so we have 20 times 8, which will give us 160. Alright, 160. But because of the negative we have over here, right, minus 160 a to the power 3 x to the power 3 plus ... Now this is the coefficient of the s cubed term. Okay, the coefficient of the s cubed term. So we write the answer and see that therefore the coefficient of the x cubed term is negative 160 a to the power what? 3. That is all that the question is asking for. It's just asking for the coefficient of the term with x to the power 3, and that is the coefficient. Okay, that is the coefficient. So you can choose to go by this using the combination, or you can go by the Pascal triangle when the power of the binomial is smaller. But when the power of the binomial becomes bigger a little, using the Pascal triangle would be a little difficult. Therefore, you may decide to use the method, or this method, which involves the combination. All right. And then you see that in writing or in finding the coefficient of the term that contains x to the power 3, we'd have to expand to that term before we get a coefficient. There is another simple method that has to do with some simple formula, and that is what we'll be looking at in the next video. So stay tuned, don't go anywhere. And then if you've not subscribed to my channel yet, make sure you hit the subscribe button, and then don't forget to like and share so that the family become big. All right, but before I go, I'm going to leave you with just few questions to try them. It says write down, without fully expanding, the coefficients of the b squared terms of the following binomials. So pause the video and then try this on your own from the practice that we just did. In the next few seconds, I will show you the answer so that you can compare with your answer. Alright, so this is what we are getting. Alright, so I believe you are getting something like this. If your answer does not look like this, then probably go through and then correct the mistakes.